Good morning. Good morning. Thank you for being here. It's amazing to see so many people interested in serverless technologies. My name is Danilo, and I'm part of the Evangelist team. And as you can imagine, since I'm here, serverless is one of the things that I'm more passionate about. Actually, I also wrote a book on serverless technologies and event-driven architectures that has been translated to Chinese and Korean. And I also work with my publisher to have a free ebook, is the last one, on agile development for serverless platforms. So the last one is free, and it's a mix of content from few books that can help you have an understanding on how to start with serverless development, how to mix that with web APIs, agile development, all the starting point that can create a good development project. And we're here because we want to understand how we can dive deeper into serverless development. So this is probably the single slide that tells the most. It's how serverless works. So we have, and I'm talking of functions now. Serverless is also a little broader as a topic. So we have here your function. It's your code. You can use lots of different languages, Node.js, Python, Java, C#. We support .NET Core 2.0. And we also added more recently Go. And there are no dependencies. You just need to know the syntax of the event that you receive from the event source. And then you can do whatever you want in your code. You can bring your own libraries. It's very easy to start. And the idea here is that the function can have access to other services. So they can read or write from a database. They can do whatever they want. They can reach any internet reachable API, even outside of AWS. And the idea is that you can coordinate this with multiple event sources. So if you build a very simple application, you can have just a function listening, for example, for new files uploaded on Amazon S3, our object storage. And then you can process these new files. But you can start chaining multiple events together. So maybe this function is processing files, then writing on a database. And this triggers another function that will aggregate information on the database and maybe write a report somewhere else. So chaining multiple events can create more complex event-driven applications and that are easier to design and to think than traditional monolithic applications. We've seen customers build lots of different things with serverless. These are the most common use cases. So web application, definitely. We will dive deeper into that also in the architectural session. And it's very easy to build backends that can provide APIs to a front end. It can be a web front end or a mobile front end. Also data processing. This is something that we will dive deeper into the architectural part in the architecture session. It's quite interesting because processing streaming data in almost real time has always been quite an issue. Now you can plug, for example, Lambda functions together with Kinesis and do very easy streaming applications. Chatbots, this is an interesting topic. This is not the AI track, but Lambda function can very easily be used to add some logic to a chatbot. This can be used for building Alexa skills, but it can also be used with multiple platforms to provide a little bit more intelligence after you understand the meaning of the sentence. And the last point is very interesting because it's sometimes also the way we've seen customers start adopting serverless, and it's IT automation. So so everybody who has a traditional IT infrastructure with virtual machines or containers, you need to run the usual housekeeping scripts that maybe clean the space, take the snapshot of the storage, do the backup of the database. Instead of having this script running somewhere that it's difficult to manage, maybe in high availability, you can have Lambda functions doing the housekeeping for you. So you can have a Lambda function that, for example, takes the snapshot of your storage and tags the snapshot in a specific way. It's much more reliable than having a script somewhere that maybe it's not running and you don't understand why. One of the most important things of serverless is that you don't pay for idle, and when you use it, you have a very fine-grained pricing model. Now, you pay by the invocations, and this is usually a very low pricing, and by the hundreds of milliseconds of execution time. How this translates to our application, it's something that we should see. The free tier, I think we already mentioned that in the State of the Union, but I think it's a good way, a good incentive to start playing with serverless technologies. Every customer, this is also after the first year, it's always true. They have the first 1 million requests per month and 400,000 gigabyte seconds of compute time without any cost. So 1 million requests is very clear. 400,000 gigabyte seconds means that if you use 1 gigabyte of memory with your functions, you have 400,000 seconds of execution time without cost. If you use less memory, you get more time because it's linear. So if you use, for example, 128 megabytes, that's the minimum that you can give to a Lambda function, you get 3.2 million of seconds of execution time. So we've seen startups, for example, building application with customers in the range of the 10,000s and still they don't have any cost from Lambda. Of course, it depends how you use the platform. And this is an example of how you can be smarter in choosing how much memory you want to give to your functions. So normally when you give your more memory, you pay a little bit more. It's linear, the cost with the memory. But you also give more CPU power to your functions. That means that the functions will run faster. So if you have a CPU-bound function, like the one that I have in this example, it's a function that is just computing all prime numbers below 1 million, and I call this function 1,000 times. So it takes lots of time. If you have 128 megabytes, it takes almost 12 seconds. If you give more memory, since this is really CPU-bound, the time decreases almost linearly. If we see the cost of the different scenarios, we see that basically they cost almost all the same. And the first and the last, they are very close in cost. But if you give 1 gigabyte of memory, you get your result in less than 1.5 seconds, so much faster. So think of that. That means run a few experiments giving more memory, because sometimes giving more memory is not really increasing your cost a lot. Maybe they increase like 10, 20%, and you get everything running faster. So do some tests. There's lots of event sources that are integrated in the AWS ecosystem with Lambda. So these are the other services that can trigger Lambda functions. So there are data stores, like, of course, S3 that I already mentioned, database like DynamoDB. There are endpoints that provide a different interface to the Lambda functions, such as the API gateway that provides a web API interface, or AWS IoT that gives an interface to IoT devices that don't or can't speak HTTPS, but maybe they can run using more machine-to-machine protocols, such as MQTT. And they can trigger Lambda functions as well. And Amazon Alexa that I already mentioned. So most of the skills are developed using Lambda functions. There are also some tools that are used for automating the development and the management of your application, such as CloudFormation, that we will dive deeper, or Code Commit, it's a managed Git repository, or CloudWatch, it's a monitoring platform that we have. And all of these can trigger Lambda function as well, and you can use this to automate, for example, your deployment, or something that happens when you do a deployment that must be automatically implemented. And there's also more event or message-oriented services, such as Amazon SNS, the notification service that we have. SES is the simple email service, so you can, for example, create an automatic service that receives emails and trigger Lambda functions to process those emails. And with CloudWatch events, you can also do cron events. That means that you can schedule the triggering of a Lambda function. And this is very common for the IT architectures or housekeeping scripts that I was mentioning before. When you execute a Lambda function, there are actually 2-3 ways you can trigger a Lambda function. So some services, like the API gateway, they trigger it synchronously. And that means that you call the Lambda function, you wait for the return value of the function, and then you give back, for example, in the case of the API gateway, the return to the customer that was calling the API. Other services, like, for example, S3, when you load a document, like an image, you trigger a Lambda functions. Those invocations are asynchronous, so S3 is just saying to the Lambda function, start with this event in input, and then S3 has no other visibility on what's happening. Usually for performance, they are less critical, because you're not waiting for them to complete. And we will see that they are, in case of errors, the retrials is different between synchronous and asynchronous platforms. And the last one is slightly different. It's actually something that we manage. for stream-based services such as Kinesis or DynamoDB streams, where we send a stream of event, and order is important, because in a database, if you first update something and then you delete it, it's different than the opposite. So we have a different way to receive the event in the same order as they are generated, because with asynchronous events, you don't have order guarantees. So if you upload 1,000 documents, then you fire 1,000 functions processing these documents, but you don't know the exact order in which these functions will be triggered. Here, the order is important. The permission model of Lambda is also very interesting and can create very interesting scenarios for the security team in your companies. There are actually two policies that you can manage. One is the execution policy, so who can trigger this Lambda function, maybe another AWS service like S3, or maybe the API gateway if you have some credentials. And then there's the permission that you give to the function itself, what the function can do when it's executed. So the function maybe can write to S3, can read from DynamoDB on a specific table, and so on. The fact that you decouple the service, the permissions in a sort of front end and back end can really help you create more secure architectures, because, for example, here you have probably the internal access to your resources, and that's very much critical, and then you can give a limited access to the invocation of the function. So think about that. It's quite interesting. Probably the most common integration of Lambda functions is with the Amazon API gateway that gives a web interface to the Lambda functions. And basically, it works that you create an API endpoint using HTTPS, so it's always secure at protocol level. Previously, the API gateway was always using CloudFront distribution. So it was CloudFront is a content delivery network. So this was what we now call edge-optimized API. That means that if you call an API in the world, you will reach our closest edge location. That's probably much closer than the region. And then you would use our own network to reach the API gateway. This works very well, but there are some scenarios where you want to have regional level. So the API is inside the region that we have. For example, if you use the API for your own application inside the region, if you use CloudFront, it would not be very optimal from a network perspective, because you will get out of the region and inside back through one of our edge location. So you can now create edge optimized or regional endpoint with the API gateway. And then when the API gateway receives an API call, what you can do is, it can map this call to a Lambda function, and that's a very common use case, but can actually call any other AWS services using the API if you want. You can also call any endpoint on Amazon EC2 or reachable over the internet. So you can use it as a sort of a reverse proxy. And this can be a good practice if you want to start adopting microservices. So you start using the API gateway in front of a web front-end API that you already have. Can be now also inside a VPC if you want, or it can be anywhere but reachable using the internet or your direct connect link. And then you can start peeling the onion and take some API and map those to Lambda functions. So it can be a good way to start mapping small functionality outside of your API. In this way, the API acts as a contract between the consumer and your implementation. And when you have a stable contract, then inside this and behind this contract, you can start changing the architecture from a more traditional one to a serverless one. And the API gateway is also writing all the information on the invocation and the time of the invocation on CloudWatch metrics. And this is interesting. I have customers that use this as an SLA report. So if you build an API for someone, basically you have all the information for an SLA report in CloudWatch, and you can just do a dump and provide the SLA report to your customers. The API gateway gives fine-grained control on the API. For example, it's protecting the access. So we already implement automatically the DDoS protection on your APIs. And you can also fine-tune throttling. And you can create different levels for your customers using API keys if you want. For example, to give bronze access, silver access, gold access. And depending on the level of the access of the API, you can give more or less throughput in the throttling. Maybe you can give free access with a very low throughput to some customers. It's actually managing the authentication and authorization in different ways. And the use of this throttling together with the API keys and levels can help you also monetize APIs because you can easily sell added value with more throughput. So when we created the API gateway, we thought of the maximum possible flexibility. So we used velocity mapping templates to map the input that you receive from the HTTP request. And this template could change this input to send the required format to the Lambda function. Velocity templates is a syntax that comes from the Apache Velocity project, so it's an open source syntax. It's very powerful. The problem is that we discovered that all the customers were doing the same template again and again, because basically HTTP requests, they have almost always the same syntax, and API and the Lambda function was expected to understand what kind of parameters were passed through this HTTP request. So we then introduced last year or 1.5 years ago, the Lambda proxy integration is now the default integration for Lambda functions, and it's what I would suggest you to use. So instead of creating these templates, you can just have a flag is the default if you use the console. And this is the input and output format that the Lambda function should use to create the backend of a web API. So the input format is giving you the HTTP method. This is a post, a get, a head. It's giving you the headers, the parameters that are passed through the query string or in the body, the full body. The API gateway now supports also binary content. So from a performance point of view, you have to be careful with large binaries through the API gateway, but it works. And in case it receives a binary content, like you upload an image to the API gateway, you have also to be careful with timeouts and sites. But it will just pass the body in this format using base64 encoding to pass the binary to the Lambda function. And the Lambda function can process this information and send a response back with the syntax that you see below. So it must send a JSON payload with a status code. This is the HTTP status code, 200.k, 404 you missed, and so on. You can optionally customize the headers, like set your own content type. You can pass a body, and then if you want, you can set the flag. This is a binary base64 encoded body, so that you can also send a binary back through the API gateway. We've seen sometimes that using binary encoding instead of JSON for large payloads can give increased performance with the API gateway. So if you see that you need to send a large payload in the return of your Lambda function to the API gateway, using a binary encoding sometimes can be better. We work a lot to improve the developer experience. So the first step that we see today now is if you want to create a very simple application, use the Lambda console. We improve it a lot. We integrated the Cloud9 editor. It's a very interactive editor that you can use through the web. We added features like managing events, seeing the dependencies of your function, what resources you can use, and also we improved the monitoring view of your functions. So without further ado, let's start see how this works. So how many people already created a Lambda function here, just that I understand? OK, I would say almost half. So I will do a basic example, but the idea is to see the features here. So this is the Lambda console, and I'm going to create a new function. I'm in Ireland. If you don't give these permissions, that is the minimum amount that you require, you don't get any log. And then it's very difficult to debug your function. So I now create a new role for template. I call the role in the same way as the function so that I can trace it back. And I don't need to attach any policy. I just need the basic permissions here. So now that we create the function, since I'm very bad with live coding and I think everybody wants to go fast on this, I have here some basic code that we can paste. And of course, the network is not so bad. OK, it's now loading. And this is the new console that we have. So first of all, let's paste the code here. And let's have a look at the new console. So here on the top, you see the dependency graph that I was mentioning. So now you see that this is a function. On the left, you see the triggers. Now there's no triggers for this function. On the right, you see the other services that this function has permissions to do something. And you see the only service is CloudWatch logs. So this function can write logs. If you don't see CloudWatch logs there, this can be a problem. So if you give other permission, you will see the dependency graph here. And here, if you click on the key, you can also see the details of the policies that I mentioned before. So this is the code that I was proposing. This is Cloud9 embedded in the console. And this is a prototype of a function. It's in JavaScript, not JS, but it's similar for every language. So you can have code outside of your functions. And this is code that we use only for initialization. So if you have something heavy, like downloading a configuration file, doing some computation that you recycle, doing multiple invocations, if you have a database connection, that's where you should put all these things. And then inside the function that we will invoke, we will reuse this multiple times. Another option is to use lazy loading. So what means is that all the resources that you need, you introduce a check in your function. The first time you see, do I have a database connection? No, I will create it. So lazy loading is another approach that is very popular. And this is the code of the function that is invoked. It's basically just logging the event, checking if the event, that it will be a JavaScript object, has a name. If it has a name, I will use this name. Otherwise, I use word. And then I say hello plus the name. And then I log it. And then I return the return value. So this is JavaScript. So we use the standard callback syntax of JavaScript. So the first parameter is the error. Null means no error. And greetings is the return value. Here at the bottom, we see some more interesting things. So you can pass now environmental variables to your function to customize your function. So if you have hopefully a different password in the database in production and in test, you don't need to change the code of your function. This is very important because you can have the same code that goes through different stages, and just the configuration is changed through environmental variables. You can tag your function. Here you have the setting with the memory. You see now from 128 up to 3 GB of memory. And with more memory, you get also more CPU. If you go beyond 1.8 GB, you start to see 2 cores in your function's environment. So if you want to use all the power of your function, you need to have at least 2 threads. Otherwise, you will not be able to use more CPU with a single thread. And the timeout, the maximum timeout is 5 minutes. 3 seconds is more than enough to say hello world. But if you have to do something that goes beyond 5 minutes, we will see there are some different ways to approach that kind of workloads. Network, you can connect your, by default, the functions are internet exposed, but you can put them inside your VPC if you want. It's slower because we need to provide, it's lower the cold start, so the first invocation is lower, the next invocation no, but the first invocation we need to provide you network connectivity. And so it's something that you should really plan for. The DLQ is a dead letter queue, so if you have a synchronous invocation of a function, you get the error immediately, and you can handle the error. If you have an asynchronous invocation of a function, like from S3, you don't know what happens. You should just check the logs. So we automatically retry asynchronous invocation 2 times. And if for the second time it doesn't work, it gets an error, we can optionally write this into a dead letter queue. It's a queue or a notification service where you can automatically or manually understand what are the input events that create an error. So it's very much used, especially in enterprise context. Here we see also the concurrency. Ian already mentioned that in the State of the Union, but now you can fine-tune the global concurrency that you have. So how many functions you can run in parallel at the same time in a region. By default, it's 1,000. We are happy to increase this limit if you want. But now, if you want, you can reserve some concurrency for a specific function. Like this function can scale up to 100. And you saw I removed 100 from my global limit. So why you would like to introduce a bottleneck in your architecture? Because sometimes the resources that are downhill from the Lambda function can scale as much as you want. So if, for example, if your Lambda function is using a database that can scale beyond 200 connections, probably you want to set this bottleneck. Another example is the VPC. So if you deploy Lambda functions in the VPC, each concurrent execution of a Lambda function will use one IP address from the subnet where you put the Lambda function. So if you run out of IP address, this is probably not good for your networking. So you should see how much IP address you have. You can allocate very large subnets for the Lambda function, but if you didn't plan or you don't need it, you can use this to limit the concurrency of your Lambda function. This is how much concurrent execution you can have. So that means that it's not the throughput per second. So if the function lasts 10 milliseconds, you can have a very high throughput with low concurrency. If the function, they last 3 seconds, then the concurrency can limit the throughput of your application more. So think of this as concurrent execution. So for now, I'm not changing this. So let's save this. If you want, you can also just put this into full screen, so you have the full editor from the console. And then we can start testing our function. So I just save it. I can test it. And let's create a first event. We can call it, so I need to pass a name here. So let's use Danilo. And I can call this with name. And I can save this new event. And this is a new feature. So you can now create test events that are stored in the console, and then you can use this for quick testing afterwards. So now I create this. And now I can test with this event. And here I get wonder of the wonder, hello Danilo, and all the logs of my function are also collected here. The other use case is if I don't give a name. So I can go here on test, configure event, and I can create a new test event that is without name. And then I give an empty object in input, an empty JSON object. And now if I go in test, I can test without a name. And I can see that I get the default hello world. So now if you continue to develop this application, you can very quickly, it's not, of course, TDD, but it's very quickly, you can just click here and test the function as you progress. So it's I think, a convenient way to work for simple projects and the first milestone. And this editor, the Cloud9 editor, is very powerful and, for example, supports different syntax. I don't see it here, but you can emulate Vim, Emacs, Sublime Text Editor, so you can find something that you're already comfortable to use. OK, so we have our first function. We tested it works. Let's make something more interesting. So next step is let's use the environmental variables. So let's make our functions a little bit more configurable. So I go back here. I replace with this content. So if you see, I'm doing something very similar to before, but I create this variable, this constant that I call salutation. And if in the environmental variable, so depending on the programming language, you can use the standard way to read your environmental variables. If there is a salutation, I take this salutation. Otherwise, I default on hello. And then I log it. And then the rest of the code is the same, but I use the salutation to build the greeting. So if I test immediately with name, I get hello Danilo. But if I go here and add an environmental variable, salutation, and I can put good morning. And since we expect you will use environmental variables also for secrets, there's a very easy option to encrypt the value in the console and then decrypt the value only inside the function in a lazy way. So the first time that you read the password of your database, you will decrypt it in memory. There's an helper code here. I'm not going through that, but it's very easy to use from the console. So now that we have a salutation, I can go back here and test my function again. And we get, of course, good morning, Danilo. So this is just an example of how you can do this. Let's look for another function that I already created that it's called greetings API. And as you can imagine, it's slightly different from this one. So instead of using this name syntax, I want to expose this wonderful API using wonderful function using a web API. So if we look at the code, is similar to the previous one. The only difference is that I'm using the syntax that we saw before. So I'm looking for query string parameters. Let me zoom a little bit. So in the event, I look for query string parameters. If there is a query string parameters, I look for a name, and then use that name. So this is basically what this means is that if you want to use the standard integration of the API gateway, you should add this mapping layer in input and in output to map from the default syntax that we proposed. And again, if you want to be compliant with the API gateway, you must send a response that contains the status code. I add a custom headers just for fun, and the body that is my hello body that I build. If you don't send this exact format to the API gateway, you will receive a 500 errors from the API gateway. So this is one of the most common errors that you can find when you start playing with this technology. So this is already saved, but it's currently not triggered. So to add the triggers, you can go here where there are most of the triggers. You select. Now I select the API gateway. And here you can choose which API. The API is a group of multiple resources. In this case, I use the default, but you can create your own API name. The API gateway has the concept of stages. So when you create a new version of an API, you can have like a test stage, a production stage. You can have also version 1 or version 2 of your APIs if you really need that. So I'm sending this in the production stage. And then there's security. The API gateway has more options than this, but this is the default security. You can use traditional AWS authentication. So that means AWS IAM. It means that the API gateway API will be protected in the same way as any AWS API, like S3 or DynamoDB, with the same syntax and the same signature. You can use an access key, or in this case, I create a completely public and open API because it's just for test. So now that we created this, I can save. And already presented with this method. I think this is the usual problem when you do lots of demos and maybe you leave the environment a little bit dirty. So let's use a new, let's call this test. I don't think I have a test stage. Add, save. Already presented on this method. So probably, I thought I deleted it, but let's say the demo would be just trivial. What you would get here, you would get an endpoint, and then you can call this endpoint using HTTPS in any way. So just passing by on this demo, it's very trivial. So with this, let's go back to the slide and move further in our content. So this is a few key combinations that I leave. You will get the slides at the end with the feedback email at the end of the event. So this is a good way you can like trigger test very quickly from command line, from your keys. So OK, we can start working with simple functions. But maybe you start to have an application with 5, 10 functions that needs to work together. How can you handle that? Probably the console is not the best way. So we have a tool. It's called CloudFormation that can help you map any complex infrastructure on AWS in a template file. And then we can use this template to build what we call a stack, an implementation of this architecture. But CloudFormation was designed far before serverless technology. So it's very verbose for serverless. That's why you already got the introduction from Ian. We introduced SAM. SAM is the serverless application model that is an extension of CloudFormation that can help you design in a template file serverless architecture in an easier way. It's an open specification, Apache 2, and it supports as an extension any syntax that CloudFormation has. This is an example of a SAM template. So here we have, we define a function. This is a serverless function, so a Lambda function. We say that this function must be triggered as an API. And this is the default for using the API gateway. And then this is the line, the transform line is the line that tells to CloudFormation that this is not a normal template, but is a SAM template. So it must apply the extension that comes with SAM and serverless. And if we pass this template file to CloudFormation, it will automatically create all these resources that are not described in my SAM template, but I would need to describe if I would directly use CloudFormation. So the function, the role, the policy, the deployment, the stage of the API, the permissions, all these things are automatically implied if not defined. And this would be the traditional CloudFormation template to do exactly the same thing. You see, it's a little bit more verbose than it should be for this use case. When you have a template, you can use the web console, but also the command line interface. This is the AWS CLI, to transform this template file into an implementation of this API. There are actually two commands, package and deploy. The package command will take this template, take all your code that should be there in the directory where you run this command, zip it, and upload it on S3. And it will produce an output template that is exactly the same as the input template, but the code will be linked to the S3 bucket. And then you can pass this output template to deploy, and this will create a stack with all the resources that are there. So there you can have 20 functions, S3 buckets, DynamoDB database, and tables, all the configurations. It will be implemented for you. If you already have the stack implemented, this can also do an upgrade. So you can, for example, upgrade your code or upgrade adding a new function. And CloudFormation will compare the current stack and what is in this template and apply the changes to update to the new version. So it's very convenient because if you add these two lines in your continuous deployment and continuous integration pipeline, you just have everything set up. So every time you want to deploy in production or in another environment, you just run these two commands one after the other, and you update the environment with the new code and the new infrastructure if required. So very convenient. Still, I think if you start to build more complex applications, it's not easy to use this syntax. Because you can have lots of relationship between the components of your architecture. That's why I created an open source project. So this is a personal project. It's not an AWS official project. It's called Serverless by Design. And you can have access at this URL. And it's a graphical front end that you can use to design what you want to build. And then it will output the SAM template so that you can then pass it and start with your application. It also supports the serverless framework if you want. It has been added since an open source project by a guy in Dubai in 24 hours when I release it. And it completely runs in the browser. So if you don't need to have internet connection, you can download the JavaScript file. It runs completely in the browser. There's no dependency and there's not any backend. So let's have a quick look at this. So this is the link. Here you have the link to the open source project on GitHub, where you can fork it. You can download the files, run it locally. And here you can start adding nodes. And a node is any entity on AWS. So let's create an API. And I call it my API. Then I can add a Lambda function that will be my backend, that is implementing the backend of my API. And then maybe this Lambda function can read and write from an S3 bucket. This is my bucket. And maybe you can also read and write from a DynamoDB table. So this is my table. And then you can add edges. Edges will connect the nodes, and it will automatically assume what you want to do. So this is an integration, this is a read and write, and this is a read and write. And then you can just put it whenever you want. And then if you want to, for example, you can say, OK, I want to add another function that is processing every time I upload so on S3. So this is my bucket processor. And another function will be triggered every time you update DynamoDB. And this is my table processor. So you see you starting to, oh, sorry, not a DynamoDB, but a new function. So this is my table processor. And again, I can just link the edge. and it will automatically understand that this is a trigger and this is a stream of data. Now that I have everything, for now I support Node.js and Python as starting code. So let's use Node.js. You can output SAM or serverless framework. I'm still looking for someone to do the Terraform part. So if there's any volunteer, I'm always recruiting. And this is my my prototype app. I can just now click on build, and this will download a zip file. If I open the zip file, I have the starting code for my functions, and the YAML file is the template. So if I go here on the command line, and let's go in the downloads, my prototype app. Now I already have the two commands that I was showing before. So and as you see, the only thing that changes here is the name of the template. So template is OK. I can just now copy these two commands. Oop. The editor is fighting back. I copy. I go here in the command line. And now I'm building this infrastructure. And now if I go on the AWS console and I go for CloudFormation, look for CloudFormation in the same region. I'm in Ireland. You see dev days, because I use dev days, not builder days, but I'm creating. Here you can see all the events. So we are creating the DynamoDB table, the roles, and here you can see the resources that are being created. And if we go, when the functions are being created on the Lambda console, we will see the empty function that I have no code, and you can start firing up your logic. So I think it's just a way to make it easier to use AWS SAM. And then if you change the code here in the directory and run these commands again, it will update this. So it's basically CI/CD, very easy to set up. And that's what we just built. So Cloud9, we saw a little bit of this new cloud development environment inside the Lambda console. But actually, we have also a service where you can have a full environment with direct disk access, where you can do a step further. So you can do what I just did, and instead of using your laptop, you can have an integrated development environment in the cloud. It's optimized for serverless, and the editor is the same as the Lambda console. But when you use it standalone, you have more features. What features? Well, one thing that we were thinking about is testing. Lots of time, people say, OK, when my serverless application starts to grow, testing is not easy. There's, of course, books written on how to test distributed architecture. But what we want to help is maybe the standard system unit test, where you want to test events and see how this event works at function level. And normally, you can do that with Lambda, but maybe you won't test locally without having to go to the cloud. And the test events that you want to test must be exactly correct. You need to use exactly the same syntax that we use. So the event that S3 would send to your function or DynamoDB would send to your function, you need to have something that is exactly the same. This is the kind of syntax I'm talking about. It's not something that you can just by memory write down. So to make it easy, we introduced some time ago SAM-local. And Paul Maddox, that is today was speaking at the container track, is one of the main authors of this tool. And it's a tool that you can install locally, can emulate Lambda function, and can help you generate events, and can also fully emulate the API gateway locally. So you can use SAM-local, for example, to generate an S3 event. You say, this is the bucket, this is the key of the object inside the bucket, and it will automatically generate the event that you would receive from S3. And then you can use this event as a text file for your unit test for a distributed, for a Lambda function. It's completely open source. It supports Java, Node.js, Python, and Go. We added Go 2 weeks ago. And it's open source on GitHub. So again, if you want to contribute and give your add more features, happy to get that. You can install it very easily. So it's written in Go. It tests JavaScript, and you install it with npm. So, and there's Docker. So it's an example of a modern application. But with npm install, you can install it locally. And then you get these commands. So basically, you can say SAM local to run local function. Let's zoom a little bit. You can also validate your template. And then you have package and deploy that are just aliases for the same commands that we used before. So the most important command is local. And with local, you get start API, invoke, and generate event. So invoke will help you invoke directly a function locally. We use Docker to simulate the same environment. So you can run on Windows, on Mac, on Linux, but Docker will always recreate the same environment that the Lambda function is expecting on AWS. You can generate events, like the S3 event, a DynamoDB event, so that you can simulate and create unit tests. And if you run start API, it will start a web server that will emulate the API gateway. And if the SAM templates as the configuration of the API gateway, those configurations will be put into the web server, so you can use the API and test the API invoking the Lambda function. So it's really powerful. And it's already integrated if you use Cloud9. So what's the next step before we do a little bit of hands-on with Cloud9? Now you can have an integrated environment also in your laptop. You can build CI/CD with those commands that I just showed you. But probably if you start to work as a team on a large project, you need to set up a full continuous integration and continuous deployment pipeline. So the idea is that your code will probably be in some Git repository. It can be GitHub. It can be our own private managed Git repositories with code commit. You can even have just a tarball on S3 that you send from any services. So if you use Bitbucket, you can just upload it on S3 when you give a Git commit. And then you can trigger automatically code build. It's our build tool. If you want, you can use Jenkins. Normally, with serverless, you need build if you use Java, C#, if you use non-interpretative languages, or if you have dependencies that you want to add during a build phase. You can use code build or third-party tools to run automatic tests using the generated events that you put. You can generate with SAM local, so you can run all your automated tests. And then you can use CloudFormation, as we saw with SAM, to do the deployment in an environment. It can be production, or can be a test environment. And here you can continue, for example, have a test environment, then a manual approval, and then the rollout in production. So it's quite easy to do. And you can design everything here graphically using Code Pipeline. It's a service that we created starting from an internal service that we use in Amazon. It's called Pipelines. And it's very convenient. And if you start using it, I think the first 5 pipelines, there's no cost. So you can really start without any cost. And then eventually, you can see if you really start using more. If you want to set up everything with just one click, we also have CodeStar. It's a service that has no cost. It's not only for serverless. So you can choose to build AWS Lambda or use EC2 or Elastic Beanstalk Code. You choose the language, and we will create the environment, the whole configuration with code pipeline, code build, to do continuous integration and continuous deployment. So it's a good way to, if you want to play with these technologies that normally are very important if you start working as a team without any cost, and just to everything is configured for you at the beginning. Last thing before we do the final demo is safe deployments. So in the State of the Union, you already heard that now we can handle the deployment of Lambda function with canary deployments, gradual linear rollouts. And this is managed by code deploy. The good news is this can also be written inside a SAM template, so that the SAM template, when you do the upgrade with those commands, can manage the canary deployment. So this is the normal template. We saw it before to create a function with the zip file of the code in this case. And you can add this section here. Globals is a new syntax that we just added to SAM that tells all these parameters must be applied, in this case, to all the functions. So you can put it once. Otherwise, you should have to repeat the same syntax for every function. So for all the function, auto-publish alias. That means that we will use the new alias to have 2 versions of a function active at the same time, the new version and the old version that was already in production. And then there are different deployment strategies. Basically, you can have, let's stay here, canary or linear deployments. So canary 10%, 10 minutes means that the new version will be rolled out for 10% of the users and for 10 minutes. Then if everything works, it will go to all the users. Otherwise, it's rolled back. Instead of canary, you can also use linear. For example, linear 10 minutes, linear 10%, 5 minutes would mean that every 5 minutes we add 10%. So it's more slower but more gradual until you reach 100%. If during this deployment there are errors, we roll back. And you can catch any custom error using hooks and alarms. So hooks are a Lambda function that you can write that can do any monitoring you want. So for example, if you do e-commerce, you can check that you're actually continuing to selling stuff and the sales didn't drop for some strange reason. Or searches works on your product catalog. It's your code. You just need to give an acknowledge that everything is working to the deployment, to code deploy, because this is handled by code deploy. And then you can also set alarms. These are CloudWatch alarms that can monitor any metric. And if one of these metrics is giving you some, like the latency of the API gateway is increasing beyond 10 seconds, or the latency on the database is growing because maybe I start to do much more writes on the database because I made a mistake in my code, these alarms can fire. So if any function or alarm gives an error, we will automatically roll back the deployment for you. So it's those two commands before, and then you can add this to manage canary or linear deployments for your infrastructure. And you can still monitor graphically what's happening from code deploy. So if you go on the code deploy console, you still see the old deployment as you saw before in the State of the Union with the gradual test. So let's see.
Can you trigger a rollback manually as well?
Yes, yes, yes. So let's see how a little bit of Cloud9 and some local on the console. So here I already have Cloud9 open. This is an environment that I have. So you see it's like an editor. Here I can have files. And here I have AWS resources. So let's go for a moment back on the Lambda console. And let's take this function that I have here that is called with great fantasy read-write from DynamoDB. And this is just reading and writing from DynamoDB. So it's exposed as an API, if I didn't make mistakes. And it's writing logs, it's writing on DynamoDB, and it's also using X-Ray. X-Ray is our monitoring and tracing framework for distributed application. What does this mean? So let's call this function. So I select the API gateway. I go here. We have the URL of the service. And I know that if I pass like an ID, I can read data. So for example, now I passed ID 123, and I'm reading from DynamoDB an item with ID 123, and I get the whole item from DynamoDB. And I can reload this function a few times. Now, if I go on the Lambda console, I can go on the monitoring tab. And the monitoring tab will tell you the invocation of the function, how much is the duration of the function, if there are any errors, throttles, DLQ errors. There's lots of information here. Now you can also select here an interval and then click to jump to logs, and it will open automatically CloudWatch logs with this interval selected. So you can see only the logs during this interval. And here you can also see the traces in X-Ray. So I enabled X-Ray tracing. So if we go on X-Ray, we see that we received some events. And I can go on service map. And this is now computing the map of my distributed architecture. For now, it's just a Lambda function. So we see that I have clients that call, this is AWS Lambda, and Lambda is calling a Lambda function. So here you can also see the cold start, because here you can see the time that is spent inside the Lambda process, the service, and what's inside this time spent in the function. And here you can see all the information on how the distribution of the time works. In the traces here, you can also see how the time is spent. So for example, this difference here is the cold start, that in this case, it's not a cold start because the function is warm, it's like slightly more than 2 milliseconds. But as you can see, there's no DynamoDB here. DynamoDB is not part of the equation. Why there's no DynamoDB? Because what I did is that I enabled in the configuration here of the function, let me debugging and error handling, I enabled active tracing. So now this function is monitored, but this is just a Lambda configuration. If I want to understand what's happening with the other services that this function is using, I need to monitor what the AWS SDK is doing. So here, if you see at the beginning, is where I create the AWS SDK. So this is JavaScript, but it's similar in any language. If I want to monitor what's happening here, I can just comment this line and use the AWS X-Ray SDK. And then the AWS X-Ray SDK is going to capture everything that the AWS SDK is doing. And it's doing tracing, not on every action. Normally, you monitor 5% of the traffic because you only need statistics here. And this is very easy, but there is a catch. So I need to add a new module to my code, the AWS X-Ray SDK. And normally, that means that I can't work in the console anymore. I need to go locally on my laptop, install the file, and upload it. Luckily, now we have code 9. So let's go. So I save it like this. I go back on code 9 that was here. I can go on AWS resources, and I can see all the functions that I have here in my region. I'm in Ireland. I can now download this Lambda function and import it locally. So now it's inside my IDE. I can go here and see that, OK, I'm using the SDK, but I don't have this SDK installed. So I can go here. I have a full prompt. I can go inside my function. And I can run, in this case, is npm install and the SDK. But you can use Maven or whatever tool you want. And you see now I have here a directory with the node modules that are being installed. As usual with Node.js, you install one thing, and there are 200 dependencies. But that's another problem. And now I have the dependency here. Everything is here. I can test the function locally if you want, using samlocal. So I can put a breakpoint here. And then I can click here and say I want to run locally. You can also emulate the API gateway locally if you want. So I can now run. I can use the debugger. And now I can run. And OK, there's like some error because probably I missed a package or something. But I can now step across the code and see the variables here that are used. So everything is like in a normal debugger. So just to make it quick, and I don't want to steal time from your lunch, let's deploy back the function with all the dependencies installed to Lambda. And it's very fast because I'm inside the region, so the network is very fast. I can go back here just for avoiding any issue. I reload the Lambda function. And now you see this is the same editor, and now I have the node modules also here. So I can work with single files. I just can't install packages from the console. And what I can do now, I can go here on the, so this is now saved already. I can go here on the API as before. I can reload my API a few times. It's working, so I didn't make mistake that broke the API code. Let's load a little bit more. Now we can go in X-ray and see if we, in the matter of a few seconds, we should start to see the new stuff coming. Now I can go on service map. I can reload. The map is updating. And now, since we are tracing the SDK, we should see any dependency. So you see now the Lambda is calling the Lambda function. The Lambda function is calling DynamoDB. I can see also the performance of DynamoDB, how that is affecting my function. If I have errors, throttles in any of these points, this works. And of course, if you have a much more complex application with different modules, this is more interesting. This is not only serverless. It works also with containers, with any. You can use the X-ray SDK even outside of AWS. It just is a tracing mechanism to learn how your application is behaving. So what are the takeaways of this first presentation? If you want to start quickly with small application, just one or two functions, you can use the Lambda console, create your test case there. It's very fast. Then if you grow, maybe 5 functions, start to use AWS SAM to describe your architecture in a template. You can use my tool if you want to create the initial template. Then it's easy to edit. You can use SAM local to generate local events, build your system unit test, and even test locally if you want. If you want to have a fully featured integrated environment, you can use Cloud9. Cloud9 is using an EC2 instance underneath that is managed by Cloud9. So Cloud9 itself has no cost. You pay for the EC2 instance that you use, and the Cloud9 is automatically shutting down the instance after 30 minutes if you don't use it. So you really pay, if you do the computation, it's the cost of EC2, even if you use it 8 hours per day during a working week, it's like probably a couple of pounds, if not less, per month. Cloud9 itself has no cost. If you want, you can also connect Cloud9 to any virtual server you have available on the internet or even locally at home, because it just needs a Linux machine to connect using SSH. And then if you go beyond, build your continuous integration, continuous deployment pipeline, work as a team, deploy in a shared code repository, and so on. And with this, I'm finishing the first session that I did on the serverless track. This was focused on the development. The next session after lunch will be focused more on the architecture, so how we can use these technologies to build architectures in different use cases. And we're, as usual, learning from our customers. So now with a lunch, we have 1 hour break, and we start at 1:30. Thank you.